Hello, everyone, and have a good evening. I hope you all and all your family are safe and healthy. This is me, Hazem Gaber from DXC Technology. DXC is always keen to add a value to the IT field and provide a new technology and capability and provide it to the markets and make a solution to the customer. This is the third year for DXC in this valuable event as organizing and corporations and presenting. And this year I got a chance to present one of our DevOps best practice, and will be the talk on this, the topic on this talk. Before beginning, I would like to thank IaC and ITIDA for their great job and organizing the DevOps Day and make it done perfectly. Also, special thanks to Andrew Kleshevert and Matt Stratton for their presence and for their great keynotes. Let's begin our, today I will talk about one of our best practice, which is Helm, using as infrastructure as a code, and how it's integrated with other DevOps tools and prepare solutions for dynamic environment. The journey will begin, and our agenda will be at the beginning. I will talk about myself, introducing myself in a few words so that you know something about me. Then we will begin to introduce, to go through the current structure and take an overview about what is the environment that we have and what is the tool that we are using and technology. Then we will see what is the challenge and what is the problem statement that trigger us to think about solutions, and we need a solution. After that, we will discuss the solutions that we provided as a best practice for our customer. Then we analyze the solutions and measure the improvement that we make on the time and make it on the workload and the effort. Last, I will talk about the future model and how it integrated with other DevOps tools and to make it done with the DevOps concept and method. Okay, about me, it's me, Hazem Gaber. I'm working for more than 10 years on the same company. We name it at the end, it's a DXC Technology. I'm working within DevOps tools and technology for more than 5 years. My current role and positions in DXC is a Service Delivery Manager and one of the DXC subject matter experts. Let's talk about the current structure, and that you give you a flavor about what is the environment that we have without going deeply in the technical details of the environment. Our environment having many microservices, and each of microservices consists of applications that are designed to perform a specific function. All these microservices integrated together to provide the business logic to the customer. You can see at the right is a simple diagram that's simplified the microservices and its connections, and that we are using and further in this slide. The microservices that we have is for backend and for front end, for caching and for database, and some Java microservices as Java application that are designed by developers to make a specific function. For example, here we have some microservices based on Java to extract some information from external interfaces outside the cluster itself. Our environment considered to be from small to medium size, as we have about 40 microservices per environment. And we have about 200 microservices for the 5 cluster that we have. And let's go a little bit about what the microservice consists of and what is its content of. Here you can see each microservice contains of some logic, some objects, and some parameters and values. These parameters is combined together to create the functionality of the of the microservice itself and make it all configurations and all parameters and security needed to perform the microservice itself. And the same for the other microservices on this diagram. For example, here we have a manifest that contains the image and the image versions. We have a deployment as the object is an important object for Kubernetes. We have a surface object that each pod or each containers communicate to each other. If some external connections needed from microservice, we have a route. Also replica numbers, how many replica for each microservice, and other parameters and objects is like environment variables. We have secrets, certifications. If some config map needed to be added to the container itself, annotations. Also resource limitation for CPU and memories that each container is used, and the parameter for readiness and liveness. And now let's have a look about the structures and the structure and the tools and technology that we use to make a difference activity and difference operations. For example, deployments, we make a end-to-end application lifecycle. We have a couple of physical servers that hold a container, and we are using Docker as a container platform, container tools to get the benefits of containerizations, of sharing resources. Also, we're using OpenShift and Kubernetes together for orchestrations that we get the benefits of managing pods and auto-scaling. We, as an operations team, work closely with the developers to create a continuous integration, continuous delivery solutions, and create a Jenkins pipeline that's perform the deployment when triggering the code through one of the SVN repository that we have. For example, we have Bitbucket or GitHub that's performs the deployments at any times whenever it's committed on the SVN. The implementation has been done and solutions is perfectly to make a deployment and can save our times and save our efforts. And the operations team is deserved to take a rest and have a cup of tea because everything is worked automatically. But this is not the case. As while the business is going, we realized that there's some still manual effort and some activity need more manual effort to be done. For that, we need to have a look and make some analysis what's going on, what's extra efforts needed from the operations team. And that's on the next slide, we will show you 2 examples and 2 scenarios about the problem and how we can solve it. On this slide, this is one of the scenarios that showing you at the beginning the normal structures as we described before. And in this case, the tester need to run test cases. For example, here, the tester need to run a regression test on the environments, and then he need to switch it back to the normal structure and need to make higher versions of the pods and testing a new component inside and then return it back to the normal structure. And he need to go switch it between different structure of the environment. And in this case, the operations teams spend efforts and spend times to switching between the structures and other. In this example, for example, from normal structures and for 2 regressions, the operations team need to increase the number of replica for each application, and he need to reminder each changes has been done to return it back. And after that, if he need to install any components and adding new environment variables, he need to consider that on the environment, and then he reverted back whenever needed. This time and manual efforts impact the agility of the project, and in some cases, the operations team is the showstopper of the completing the sprint. So this is one of the examples that we need to think about accelerating or something to make it more flexible or more faster to make to overcome this switching, depend on the requirement of the business and the project. Here's another example describe the challenge and the issue that we have, for example, production structure, and for some reason we need to clone this production structure to another platform or another cluster, or maybe using for a disaster recovery, we need to build an environment with the same structure, with same security settings of the production. And in this case, the operations team need to taking the objects and taking all microservices and then build a new environment with the new structures and considering all configuration needed, and need to make a performance test that everything is working fine and so on. This is also consume a lot of time and consuming a lot of effort from teams to build this structure. Now, let's summarize the problem in words that we can summarize that managing a whole manifest can be difficult. So we need to take care of the objects and taking care about each configurations and each security group and everything we needed to be considered, which is taking time and effort, and it's very difficult. No template parameterizations, as it's important for automations to have parameters, and we have standards, so we adding these together to make automations. No application lifecycle hook, and also this is needed for CI/CD implementations. No history of a release, and this is to make sure that we can go back and forward with the releases as simple as we need in the deployment lifecycle. So what is the solution? The solution that we need to implement the infrastructure as a code, as it's a technique and practice and tools applied to create reusable, maintainables, extensibles, and testables infrastructure. And this is all aspect that we needed on this, in our cases. The benefits of using infrastructure as a code, you can see on the right that this is the commercial study conducted by Microsoft in 2015, and this study can show us the benefits of using infrastructure as a code for both developer and operations. That we can see that it's about 24 to 55% better collaborations between dev and IT team, IT operations team. Also, it's about 33% faster configurations workflow and faster application lifecycle overall. About 33% fewer configuration error, which is very important on making changing on the infrastructure, and also it can be frequently apply more releases by 36%. In our cases, our scenario, that the benefit that we can get is the standardizations of the release implementation, and they get a suffer fast change with low risk and without human mistakes, and the fast response to the IT requirements, high security as applying the same security for the cloned environment or when switching the environment or changing the structure, and infra versioning and history. That we have a history of the environment that we can book to any environment structures, if it's old or if it's a new one. So what are the tools that can overcome the mentioned problems and challenges and can get a benefit of infrastructure as a code and fulfill our requirements? The Helm is the mentioned tool or the targeted tool here. And the Helm is by definition the packet manager for our Kubernetes. We can think about Helm as a DNA of the environment and overall releases and that contain all objects and configurations, all object parameters, all object configurations, and all manifests that can build the environment as we require and as we need it. Let's go now inside the Helm and see how the Helm working. As we know, for each microservice consists of many Kubernetes objects, We collect these objects on a YAML file and then create a Helm chart that contain all these YAML file on the template. We make up parameters and value and put it a value file value.yaml file that's having the parameters of the environments, and we can change it as we need or as is required by the tester. So when using Helm and created a release, it's created all objects or Kubernetes objects from these YAML files, and from the parameters files, it can change the parameter of the environment as required and as we need, and get the desired state at the end. And this is example how it looks the charts. We have here example of 3 Docker containers, each have images, images versions, and have a multi-Kubernetes objective. Here's have a deployment, we have a route, we have a surface, we have a config map, we have a secrets. All these combined together to create the Helm chart that can be used to build the Kubernetes, to build the environment structure as we need. And now let's see how implementing the Helm tools can help on solving the challenges that we discussed. Here on this example, the tester needs to switch between the environment and the structure. Helm can be used to use the Helm chart that build the environment, and using the parameter file that have the environment changes, and simply we applied the Helm chart for each environment that we needed, and it's created the needed environments in seconds, or we can say in minutes, in a few minutes. In the other example also, all what you need to clone the production environment or any environment are migrated for any purpose needed, or any other surface, cloud service providers, or on any other cluster. All we needed is to use the Helm chart and created the environment. And then Helm releases created the environment structures with the environment object with all configurations and all security aspects needed. And here are the benefits of using Helm, that we get fast infrastructure changing times, deployment or migrations or cloning. We get a high performance and accuracy with 0 human mistakes. Safe infra designing and keep the history of the releases that can we switch it to any releases as we need. 100% replicated and easy to share, and anyone can use the same chart and get the same result, and can be integrated with other DevOps tools. And after implementing the solution, we make analysis and we make to see the gain and see the benefits of using the Helm chart. We find that on our project that we have a 25 times faster than the manual method, as it saves more than 40 hours in one of our projects, that we comparing the manual methods comparing with automation using Helm. Also, it's about 90% manual effort reduction and almost 0 human mistakes. This based on the analysis and tracking the activity and the efforts after and before applying the solutions and after applying the solution. And now Helm has been added to the other DevOps tool that can be integrated to perform the deployments and migration and cloning the environments and all over the release, as well as the application version. Now, developer can commit the code on one of the SVN repositories, even GitHub or Puppet. This trigger the Jenkins pipeline to build the image with the new versions, and using Helm chart and parameter files to create all Kubernetes objects with the required structures as on the Helm chart itself. And this is show here how Jenkins can be triggered to create a Helm releases to build the environment based on the parameter and to provide all requirements or all environment requirement structure. And now the operations team is no more supposed to run the project, and the agility of the project is going further. And now they can take a cup of tea while taking or monitoring the Jenkins pipelines workflow. I hope it's interesting for you, and I hope I'm adding something new. Thank you for listening.